Mangrove species identification is commonly done using identification keys such as Tomlinson 1986, Jason et al. 2006, etc. The reality in the field, it is sometimes difficult to open and identify species using those identification keybooks. A correct and rapid science identification strategy or trick will be more useful and practical. In this video tutorial, we will show you how to identify mangrove species using an easy, fast, and precise using our experiences on doing mangrove monitoring for the Core Map CTI project. So, without further ado, let's learn those tricks. First, a simple way to identify mangrove species is by learning the common types of their root morphology. In general, a mangrove genus shares a typical root system, which differs from the root system of other terrestrial plants. The stilt root or prop root with wide coverage is the main character of genus Rhizopora. Other members of the Rhizoporaceae family such as Bruguiera and Cereops also have similar root types, even though their coverage is not as wide as Rhizopora. Stilt root in Bruguiera and Cereops are only attached to the lowest part of their stem. Besides the prop root, both species also have another type of root called knee root. This type of root appears above the ground surrounding the main stem. The size of Bruguiera knee root is bigger compared to Cereops. Another unique root system is breathing root or pneumatophore. This type of root belongs to genus Soneratia and Avicennia. Breathing root in Soneratia is harder and stiffer compared to Avicennia, with a more flexible breathing root. This type of root is also found in a species of Xylocarpus group called Xylocarpus moluccensis. The breathing root in this species is stiff, but morphologically more flat-shaped roots with a round tip. Another unique root type is plank root found only in Xylocarpus granatum. However, other characteristics of this species need to be observed as well. Next step on practical identification of mangrove species is by observing the fruit and flower of the mangrove stand. The observation of this character is one of the easiest way to distinguish mangrove species. The weakness of using this character as a reference is the different flowering season of each species. Often, we did not find a single flower or fruit during the sampling period. From the aforementioned root type, we already sort out every common genus that was mostly found during the field sampling. This is the flower of genus Rhizopora. All species members of this genus can be easily distinguished based on the number of flowers found in a single inflorescence. Rhizopora apiculata has 2 flowers with a short peduncle. Rhizopora ex Lamarcki also has 2 flowers in a single inflorescence, but their peduncle is longer than Rhizopora apiculata. Rhizopora mucoronata has 4 to 7 flowers in a single peduncle. Meanwhile, Rhizopora stylosa has 8 to 12 small flowers. It is quite easy to differentiate each species of the genus Bruguiera if the flower and fruits are present. Bruguiera gymnorrhiza is a common species found in Indonesia with red calyx or petals. Bruguiera cylindrica has small, paired flowers and fruits. This image shows the differences between each species in genus Bruguiera based on the character of their fruit and flower. Cereops is another member of the Rhizoporaceae group with a significant difference in its fruit. Cereops tagal has longer propagules compared to Cereops decandra and Cereops zippeliana. Propagules of Cereops tagal hangs in the direction of gravity. Meanwhile, Cereops decandra and Cereops zippeliana hang in the opposite direction of the gravity. Both species can be distinguished based on the color of their propagule. Cereops zippeliana has red propagules, and Cereops decandra has white propagules. Genus Lumnitzeira has a striking flower and fruit color. There are two common Lumnitzeira species found in Indonesia, that is Lumnitzeira littorea with red flower and Lumnitzeira racemosa with white flower. Genus Xylocarpus has a typical flower compared to the other mangrove groups. The flower morphology of Xylocarpus granatum and Xylocarpus mollusensis are not so easy to distinguish. However, they are quite easy to distinguish if we observe their fruit. Both species have a round fruit with 2 or 3 times bigger than a tennis ball. However, Xylocarpus granatum fruit color is yellowish brown, while Xylocarpus mollusensis has green-colored fruit. Let's move on to the commonly found mangrove groups in the seaward zone. In the coastal zone, or the zone closest to the sea, the substance is sandy or rocky, and here we can find the genus Soneracea. Soneracea alba has a unique flower and fruit. This is how the flower looks like. The color is dominantly white, which comprises mainly of its stamen. Soneracea cassiolaris has a red-colored flower. Both species have a similarly shaped fruit. Another species from this genus is Soneracea ovata, with white flower and fruit that is partially covered by the calyx lobes that bend toward the fruit. Avicennia is a genus mainly found living in the muddy substrate with high salinity. The flower and fruit of Avicennia species can be identified from this picture. Besides those genera, there are still many mangrove species that we can find in the study site, such as Nipa, Camptostemon, Aegiceras, Exocaria, Pempis, Osbornia, etc. When in doubt during the field identification, we recommend collecting parts of the mangroves such as leaf, fruit, and flower. Besides that, documenting the mangrove stand will also come in handy. The leaf morphology and color can give proper information on a simple mangrove identification. Rhizopora has a pointy leaf with a needle-like structure as the tip of the leaf lamina. The proportion of their petiole to lamina is 1/10 and almost the same throughout all species in the genus. Bruguiera has a similar leaf shape with Rhizopora, but bigger ratio of petiole to lamina, that is 1/3 or 1/4. Cereops is the only genus of Rhizoporaceae with a small and rounded tip leaves. The leaf size is very useful to differentiate species in the mangrove group. As an example, in the Rhizopora group, Rhizopora mucronata has the biggest leaf size within the group. Rhizopora apiculata has an elongated leaf shape and Rhizopora stylosa has a similar leaf ratio of length to width as Rhizopora mucronata with smaller and more flexible leaf. In Bruguiera group, Bruguiera gymnorrhiza has the biggest leaf lamina size. Other species of this group, such as Bruguiera sexangula, Bruguiera cylindrica, Bruguiera parviflora, and Bruguiera exaristata, have an almost similar leaf size but smaller compared to Bruguiera gymnorrhiza. Cereops tagal has a wavy and smaller leaf lamina size compared to Cereops decandra. Next, we move on to the land part of the mangrove forest. Mangrove species found mostly here are Lumnizera litoria and Lumnizera racemosa. Based on its leaf morphological and size, both species are difficult to distinguish. However, their petiole color differs. Lumnizera racemosa leaf has a light green petiole, while Lumnizera litoria leaf has a reddish-dark green color. Similar color also appears in their blooming petals. Two other mangrove groups are commonly found in the seaward zone of mangrove forest area or near to the sea. Those groups are Soneraceae and Avicennia. There are three Soneraceae species commonly found in Indonesian mangroves. They are Soneracea alba, Soneracea caseolaris, and Soneracea ovata. These three species have minor differences in their foliar shape, size, and leaf arrangements as shown in the following video. Next, leaf morphology also a key character to distinguish between the species of the family Avicenniaceae. Let's see the differences from this picture. Several other characteristics are easily observed and can be used as a practical guide to identify mangrove species. As an example, the trunk of Xylocarpus mollucensis that differ with Xylocarpus granatum. The brown-colored trunk of Soneracea alba is easily distinguished with Soneracea ovata and Soneracea caseolaris. The latter two species have a trunk with white spots, which makes the trunk appears as white color. The unique terminal branch of Soneracea caseolaris also differs from the other species. Its terminal branch looks as if it has fallen following the gravity. The branch is shaped like a square with some leaves growing on it. Habitat is an important reference for the identification of Soneracea. Soneracea alba usually grows in a sandy area with high salinity. Meanwhile, Soneracea caseolaris and Soneracea ovata are commonly found at a lower salinity area or mangrove forests along the river.